These are your 10.3a notes on geometric sequences. We are going to, in the next two sections of notes, study geometric sequences and then geometric series. So a geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a constant called the common ratio. So instead of having a common difference that we add each time, we're going to multiply by what's called a common ratio. The first term can be any number, so that's why the pattern really starts after you have the first term. So the common ratio, to figure that out, you divide any term by the previous term. Okay, and so a geometric sequence can increase by multiplying by a whole number greater than 1. So times by 2, times by 2. The sequence is going to get larger and larger and larger. If the sequence is getting smaller, that means you're multiplying by a fraction. So somewhere between 0 and 1, like maybe a half. Take a half times a half times a half. So it's all multiplication, but when you take half of something, it's just like division, but we write it as a multiplication. You can't have a common ratio of 1 because then there'd be no change. So the formula now that we have for today, there's actually two of them. I'm not a big fan of the first one, but to find the nth term, a sub n, remember that's your last term or the next term of the geometric sequence. You still have a sub 1 as the first term. Common ratio is r, and you can use one of these two formulas. So to find one term, you could take the previous term and times it by r. Really not needed unless you have the previous term. So if you have the 8th term and they want the 9th, then you can use that formula, but that formula is kind of obsolete. So this is the one that we're really going to concentrate on. So if you want to find the nth term, you take the first term and you times it by r to the n minus 1 power. Okay, lots of order of operations here again. So just the order in which you do things. You can find a sub n using that formula. You find a sub 1 using that formula. You can find r using that formula, and you can even find n. Geometric means are the missing terms in between non-consecutive terms. So if I have these three terms in between a sub 1 and a sub n, this would be considered three geometric means. I cannot stress the importance of vocab here. You need to know what a sub n represents, what a sub 1 represents, what r represents, and what n represents. So we're going to go through these. The challenge is just understanding how do you use that formula. Find the nth term of the geometric sequence. Okay, they're giving us a sub 4, and they want us to find a sub 5. So this is where we could just take a sub. To find a sub 5, we would just take a sub 4 and times it by r. So this is that first formula. Really, you can only use it if you have this relationship where they give you 4 and they want 5. Okay, and so a sub 5 then, the fifth term would be 10 times the r value, which is a half. So a sub 5 then would be 5. Another way to do that problem is we could actually temporarily just call this a sub 4 a sub 1. If that becomes a sub 1, then you're not looking for the fifth term, we're looking for the second term. And then you could use the other formula. So sometimes you have to do that. If you look at number 2, that's going to apply here. They give us the sixth term is 729, and they want us to find the ninth term. So I have 729 is the sixth. That's a sub 6. Here's a sub 7, 8, and here's a sub 9. I really don't want to have to find the other terms in between. I just want the ninth term. And so we know that the common ratio is timesing by 3. So what I can do to use my formula is I can set it up this way. And really, I know it says a sub 6, but I can call a sub 6 temporarily a sub 1, which really means this is a sub 2, 3, and 4. So this would be a sub 4. Now I have enough information to find all the, use the formula. A sub 4 is equal to a sub 1 times r to the n minus 1. The fourth term, starting with 729, timesing it by 3 to the 4 minus 1 power. Now, your n value changed because we're not counting from 1 to 9. We're starting at 6 and counting to 9. And so to get this, using the order of operations, I got to do my power. So I get a sub 4 is equal to 729 times 3 to the third. And 3 to the third is really 27. And so a sub 4 is going to be 729 times 27, 19,683. Now I know you can just times this by 3, times that by 3, and times it by 3 again, and you'll get the same answer. That is not what I'm looking for. I will be looking for this whole process because that's the algebra. Okay, so we're writing a formula. We're using the formula. I multiply by 3 times. Okay, that's why it's 4 minus 1 gives me the 3 times because I have 4 terms, but I already have the first term. So of the 4 terms, I just need 3 more. So there's a repetitious times 3 times by 3 times by 3. And when you do repetitious multiplication, it becomes a power of 3, 3 cubed. That's kind of where the whole formula comes about. So this gets a little bit more involved than with the arithmetic, but same idea. You need to use the formula, manipulate the numbers to do as such. All right, so find the 3 geometric means between 3.12. That means there's going to be 3 numbers existing between them. And we're going to end at 49.92. Okay, the only formula we have is a sub n is equal to a sub 1 times r to the n minus 1. So when I look at this, I do have a sub n. That's my last number. I have the first number, a sub 1. And if there's 3 geometric means between these 2 numbers, that tells me that n is equal to 5. I know the number of terms is 5. The only thing I am lacking is the r value. I don't know what I'm multiplying by to get from 3.12 to 49.92. So I got to plug these in and do some solving for r. 49.92 is equal to 3.12 times r to the 5 minus 1 power. I'm going to divide by 3.12 to get r by itself. And I can also, while I divide, I can subtract that 5 minus 1 there. So I have 49.92 divided by 3.12. I get 16 is equal to r to the 4th. To undo the 4th power of something, you take the 4th root, take the 4th root, and r is going to equal positive and negative 2. When you have an even amount, an even index, you have to say that I could have multiplied 2 by itself 4 times to get 16, or negative 2 by itself to get 16. So since they both give a positive 16, we have to include the plus or minus. Now, if it was an odd amount, you can't do that, because if you have an odd amount of multiplications, a negative would in fact be negative. So what this tells me is that there's actually 2 different sets of geometric means. If I multiplied by a positive 2 each time, if I times by 2, I would get 6.24. And then times by 2 again, I would get 12.48. And times by 2 again, I get 24.96. And then if I times by 2 again, I'll end at 49.92. All positive. But in addition to that, if I multiply by negative 2, I get a negative 6.24. And when I multiply that negative by another negative 2, I still get a positive 12.48. Times by a negative 2 makes a negative 24.96. And then when I multiply that by negative 2, it works out to be a positive 49.92. So when I answer this, I'm going to write my answer as both positive and negative 6.24, just a positive 12.48, and then a positive and negative 24.96. You can list them as separate numbers, or you can list them like this. So notice the 12.48 is not both positive and negative because the negative turned into a positive and the positive just stayed positive. So a little bit more confusing there. Just remember, when you take an even index, I took the 4th root of something, I have to include the both positive and negative. So there you have it in a nutshell. use that formula. I want you to do, tell me what R represents in a geometric sequence. Give me the definition of R. And then I want you to find the seventh term of that sequence. You have to use either these two numbers or these two numbers to determine what your R value is equal to before you can figure that out. So divide to figure out what are you multiplying by each time to get the next number. Good luck.